So when we are talking about sets, what you want to understand is how you can work out simple things like an intersection of a set, the inverse of set. So say I've got elements. Here is a set A, and say it has got elements 1, 2, 3, 4, and 5. And say I've got another set B that also has got elements. Say it has got the elements 4, 5, 6. So these two sets, there are a lot of operations that we can work on them. We can find the intersection. So that is going to be A intersection B. Now just a reminder, intersection is what is appearing in the set A and in the set B. So is there anyone that wants to help us? What is going to be the intersection of A and B in this case? What can you see in the set A which is also in the set B? So let's be free to interact. This is when the class is going to be enjoyable. This is when you're going to be reminded of things that you might have forgotten from high school and also learn new things. Anyone that can help here? What is the intersection of the two sets? So when you want to speak, you just press on your, there's a microphone on your phone, open it, and then you can now be able to contribute. So what you can see in these two sets, you can see there is a 4 here, there's also a 4 there, there is a 5, there's also a 5. So 4 and 5 are in both sets. So that is going to form the intersection. You can also find the union of these two sets, A union B. Now union means combining the sets. So in A we have got 1, we have got 2, we have got 3, we have got 4, we have got 5. In the set B we have got 4, 5 and 6. So just put 6 there. You don't write the same number twice. So I haven't written 4 and 5 again. So this is the union of the two sets. That's how you work it out. Now you bear defined questions where we've been given elements. So what I'm from dealing with are known as elements. So what we're interested in dealing with here are not elements but a range of values. So what do we mean when we're talking about range of values? Let's say for example you've got numbers from 2 up to 5. If you are talking about all numbers from 2 up to 5, like this, you can write this as a set, and what you do is you write 2 comma 5. Now as you can see on 2 and 5 I've put a circle there, right? I've not shaded that circle, so we call these as open intervals. So you put them like this. What are we saying? These are open intervals. An interval means that you are talking about all numbers from 2 up to 5, but you are not including 2 and you are not including 5. That's the meaning of an interval. All numbers from 2 to 5. And the thing is that you can't list them unless if you are moving in whole numbers. From 2 you are going to go to 3, and then you are going to go to 4, and then you are going to go to 5. But if this is a set of real numbers just between 2 and 3, you have got 2.1, 2.2, 2.3, 2.4, 2.5, up to 2.9. But still you can't list because you also have 2.001, 2.0001, 2.000001. So in other words, when you're talking about a range, there is no way for you to list the elements because there are too many. And in such a case, that's when you use a range. You can have another set, let's say a set like this one, and you have the same one from 2 up to 5. But look at the difference. Here I have shaded, and I've also shaded here. So this set, the way you write it is, you look at the type of brackets I'm using. So you write it like this: 2 comma 5. These brackets, we call them closed intervals. Closed interval. So closed interval means that we are talking about all the numbers from 2 to 5, including 2 itself and also including 5. That's closed. Open, you are talking about all the numbers from 2 to 5, but you are not including 2 and you are not including 5. You can also have another type. Say you are talking about the same 2 up to 5, but say I shade on 2 and then on 5 I have not shaded. So the way we write this is, you are going to put this kind of bracket at on 2 comma, and then I'm going to put 5 on 5. I'm going to put like this, you can see. So this is it. We started with the one that is closed, so this is known as a closed open interval, because we started with closed and then we went to open. Okay, so these are the things you need to understand when you're dealing with sets in at this level. The elements, when I write this, use these brackets like this, these are known as curly brackets. These ones represent elements, elements, not a range. For example, I can say 1 comma 2 comma 3 comma 4. But when you are using this type of brackets, these or these, you only put two things there, two numbers. You always start with a small number. So always start with a small number and then write a big number. And this is telling you where you are starting and where you are ending. It's not correct to write like this, because you should always start with a small number and then write a big number. Let's say, for example, they've given you a number line and there is a number here, let's say 2, and then they've put a set here like this, and then let's say you have got a number here, let's say it's a 5, and then there's another set here. Let's say this is the set, the one on top is a set A, the one down is a set B. If you look at the one which is on top, which is the set A, if you want to write it as a set interval, you look at where the set is starting. What is the smallest number? You are looking at the smallest number. The smallest number here is a 2. And then which one is the biggest? Can you see that the arrow is going in this direction? It's not ending, so we don't know where we're going to end. So we are going all the way up to infinity. But at 2, you can see I've not shaded that, so it is open. At infinity, it is also going to be open. For infinity, you always use open, always, because you don't know what the number is. If you look at the set B, the small numbers are actually on the left, big numbers are on the right. So where the arrow is pointing, that's where the small number is. So we have got negative infinity this side, because we have got an arrow. We are going to small numbers, but we are not ending. So the only way you are going to show that it's a very small number where you are going to put negative, that's negative infinity. And then we are going all the way up to 5, so 5 is a bigger number there. Let's say if I had shaded here, so on 5 I'm going to close. But on negative infinity, infinity you always put open. There's no way you can put close for infinity. So these are the two sets. And it's very important for you to be able to know how to write them. Is there anyone who has got a question? Or it is okay? Okay, let's do some questions. Let's say, for example, we've been given a set A, which is coming from 1. Yes, please. Oh, you can't see anything. Is there anyone who can see so that I just confirm if the problem is not with me here? Okay. So is it shalom? Should be the network or something there. You can just try to disconnect and then connect back. You're going to see, I think. Okay. So let's say I've got set A, which is from 1 up to 5, and then we have got set B. Let's say it is from 0 up to 2. I can close here. And then they say find the following and show on the number line. So we want to find and show on the number line. Let's say the first one we want to find is A intersection B. The second one we want to find is A union B. The third one we want to find is A minus B. These are three. So starting with A intersection B, we are going to write our number line. The set A is from 1 up to 5. So here I'm going to shade. Even here I'm going to shade. This is the set A because you can see both were closed. The set B starting from 0. 0 is going to be on the left of 1 up to 2. 2 is going to be somewhere here. On 0 it is open. On 2 it is closed. So we'll shade there. And then I'm going to, this is the set B. Remember we want A intersection B. So the intersection is where these two sets are meeting. So you do like this. So the intersection of these two sets is this region that I've shaded. Therefore say A intersection B is equal to, you can see the smallest number is here and that's a 1. The biggest number is this one and that is a 2. So the next thing now we need to do is what kind of brackets are we going to use. You can see on 1 is part of the set A and 1 is also part of the set B because it's in the line, it is within the range. So we're going to close because 1 is falling in both sets. And then look at 2. In B I've shaded there, meaning that 2 is part of B. And then in A you can see 2 is falling on the line. So if anything is falling within the line, it means that it's part of the set. So 2 is part of A and B, meaning that it's part of both sets, it's part of the intersection. So we're also going to close there. So this is how we are going to be able to show there. So we have showed on the number line and then written the set. This is how exam will come. Find the following and show them on a number line. So I've showed on a number line like that. You can say I've shaded, just shade like that. And then we can do the second part of the question. Okay, be free to ask in case you've got a question. So the second part of the question, we want to find A union B. But okay, so we said A is from 1 up to 5 and we shaded on 1 and on 5 because that's the way the question has been given. And then B is starting from 0 up to 2 like this. It's open here but it is closed on 2. That's how it has been given. So we are saying that our intersection where these two sets are meeting is this region. this region here. So to tell if it's going to if our set is going to be our element is going to be included or not, if you look at 1 for set B, 1 is part, you can see it's on a number line, it's within the number line. So meaning that 1 is part of set B because B is from 0 up to 2. And then 1 is also part of the set A, you can see, because we're starting from 1 up to 5. So 1 is also part of the set A. So since 1 is in both sets, meaning that it's going to be part of the intersection, it's going to be found in both. And then if you look at 2, it is closed here, meaning that it is part of set B. And then it is also on the line, meaning that it is part of the set A. It is within the set A because A is from 1 up to 5. So B is in both sets, meaning that it's going to be part of the intersection. Does that make sense? All right. And then the second part of the question is we want to find A union B. Now A union B is easy because we are just combining. Can you see that combining the two sets? If you combine the set A and the set B, the smallest value you have is 0. Combining is more like forming a straight line. You can see from 0 are going to go to 2, and then from 2, that's where set B is ending. You are going to continue like this up to 5. So the set A union B is starting from 1 up to 5. In other words, when you combine these two sets, actually we are starting from 0, not from 1, because to be a combination of this and also this. So just get the two sets, that is a combination from 0 up to 5. Now A minus B, this is what thing you need to know. If you see a minus, it means that you want what is in A but not in B. So A minus B should be in A but not in B. So if you look at this is A, so you want those elements that are in A but not in B. Can you see that from 2 up to 5 the elements are in A but they are not in B, because what is in A and is also in B is these. You can see these ones here. They are in A, they are also in B. But from 2 up to 5, they are only in A, they are not in B. And if you can see, I've put open on 2 because 2 was part of B. But I just want what is in A but not in B. So already I've shown it means the answer is from 2 up to 5. At 2 are going to open, 5 we are closing because 5 is part of A. Now A, another way you can work out this one is you knowing the meaning of A minus B. A minus B means A, okay, just a moment. Okay, so we continue. So I was saying that when you have got A minus B, it means A intersection B complement. So the one that has got a minus is where you put a complement. Okay, so if it was B minus A, it would be B intersection A complement. This is a principle you need to know. It will come in your papers, it will come, so it's a very important principle. Please never forget that. So therefore, now we are going to go on our number line. Okay, so what you want to start with is always start with the one that has got a complement. It will be easier. So the set B starting from 0 up to the set up to 2. So we have got from, we are not including 0, but we are including 2. This is the set B, but we want B complement. So at 2, can you see that at 2 I've shaded, so the complement I'll not shade, and then I'll be going this side because I want what is outside. And then at 0 I have not shaded, meaning for the complement I'm going to shade. Since 0 is not part of the set B, meaning that it is outside B, that's why I've shaded. And then I've going to be going in this direction. So what I've written in white is known as B complement. So it is this B complement that we want to see where it meets with the set A. And the set A is starting from 1 up to 5. And 1 we are shading, 5 we are also shading. This is the set A. So we want where these white lines that I've drawn are going to be meeting, they are going to be intersecting. So you can see they are going to intersect from here up to here. So this is the intersection point. Okay, this one. So therefore, what is A intersection B complement? You can see they are meeting from 2 up to 5. Now when you look at 2, 2 is part of the set A, but 2 is not part of the set B complement. Why? Because it is open here. Can you see? So 2 is not part of the B complement. So since 2 is not in both sets, we are going to open. It's not part of the intersection. And then for A, you can see A, 5 we have shaded, right? So 5 is part of A, and 5 is also part of this line. So 5 in both sets. So we are going to close because it's in both sets. You can see this is what we already found earlier on. Does this make sense? Is there anyone that has got a question? So just to make sure that we've cemented this, let's use some questions from the UNZA exams. We have got, given that set A is from -3 to 2, B is from 0 to 7, C is from -5 to 1, and we've also been given the universal set from -10 to 10. We want to find A intersection B complement. So A intersection B complement, this is the same as A minus B. Please, if you see a C on top, that's a complement. They can just put also this one. It's the same. A intersection B complement. This is the same as A minus B. So what are we going to do in that case? We'll still write a number line. And then our set A is what? Remember I said you all start with the one that has got a complement. So go to the set with a complement that is a B, and B is from 0 to 7. Okay, so say 0 is here, 7 is here, and it is closed at both ends. So we'll shade on 0, we'll also shade on 7, yes. So this is a set B. Now we're interested in what? B complement. What is outside B? So what is outside B? I'm going to start from 0. I'm not going to shade right because 0 is part of the set B. I'll be going in this direction. And then I'm going to shade also here. I'll be going in this direction, right? Now, for this one, I'm not going to put arrows. You know why I'm not going to put arrows? Because for the example that I just gave you, I didn't specify the universal set. Universal set tells you where you end. Here, they've told you the universal set. They've told you your limits. You can't go beyond -10. You can't go beyond +10. That's the universal set. So for every question that you are dealing with, always make sure that you take note of the universal set. So the universal set, we can only go up to 10, and we can only go up to -10. Please never exceed the universal set. So therefore, I'm going to go like this. I'm just going to reach to the universal set. But because it is open on -10 and +10, it means that the -10 is not part of the universal set. And also the +10 is not part of the universal set. So I've opened on both ends. So this one I've written is B complement. Is there anyone that is left behind? Anyone that is left behind? Okay, now that we know B complement, now we can get the set A. And the set A is from negative 3 to 2, so negative 3 will be, let's say, somewhere here, and then 2 is somewhere here. Negative 3 is going to be open because we've used an open bracket, and then 2 is going to be closed. Remember, I want where A is intersecting with B complement. B complement is in green, A is in white. So we want where these two sets are intersecting. Therefore, I'm going to come like this. That is B in green, and then this is the A. B complement, sorry, and A. So this is the point of intersection that I've put. Therefore, this means that A intersection B complement is going to be equal to from negative 3 up to 0. But look at negative 3. It is not part of A, so meaning it can't be part of the intersection. I'm going to open. Look at B. Sorry, look at 0. 0 is not part of B complement because it's open there. So I'm also going to open here. Okay. So the thing is that if you just miss the brackets, I've seen the way they marked some papers. This is the 3 marks. You lose the 3 marks just because of missing a bracket. Some who are good can give you maybe 2 marks if you've just missed 1 bracket or 1 mark. Others will just give you a 0. So make sure that you pay attention to the brackets. Is this question okay? Is there anyone that has got a question? Alright. So we can now do the second part of the question, which is A minus B minus C complement. Now this one is A minus B minus C with a complement. See, sets are easy, but don't try to write everything at once. It will confuse you. It will confuse you. Okay? Move with them step by step. So the way this question is, you can take the entire of this thing here as one thing, so that you change this minus. Remember what we said minus is? If you have got a minus, it means that it is A intersection. So whatsoever is in this side, you put a complement. If it was B, it was B, A intersection B complement, isn't it? That's what we said. So since it's B minus C, we are going to say A intersection B minus C, put a complement. But remember, there is already another complement there, so you have got two complements. Now when you have got two complements, they cancel each other. Therefore, this means that this is just A intersection B minus C. And then remember again, B minus C, what does it mean? It means A intersection, get the B, put intersection, and then this C, put a complement. Okay, that's the meaning. Is there anyone that is confused on simplifying? Because if you can't simplify up to this end, you can't answer the question. Is this okay? Yes. Shalom. Okay. So when you are simplifying, you can see we have got A minus B minus C complement. What you need to know is when you have got X minus Y, this means get X, change this minus to intersection. But the second thing, this Y, is going to carry a complement. This is how you simplify these sets. The second part is what carries a complement. So for this question, we have got A minus B minus C complement. So this is the first part, minus the entire of this thing. We are going to consider it as the second part. So when you are changing it, it becomes A. Remember, changing to intersection. But the entire of the second part, B minus C, is supposed to carry what? A complement. But remember, it already has got another complement there. Is this okay up to here? Okay, good. So every time you see a letter with two complements, those two complements cancel each other. It means that it's just that letter alone. So y complement complement is just y. So because we've got these two complements, they are going to cancel each other. We are just going to have b minus c. Is this okay?
Mm.
Good. And then b minus c also, remember, because you have got a minus, write b, change the minus c into a complement, so it becomes intersection. Remember the second letter, just put a complement there. Is that okay?
Yes, yeah.
Yes. So this is how you simplify. Okay. So we have simplified it like this. So please don't confuse it. Don't write this complement outside this one. Don't write it outside because C is inside the brackets. Make sure that the complement is also on C inside the brackets. Because if you put it outside, it means something totally different. And then now we can go on our number line to start finding, because we've been told find each of the following and represent them on a number line. Remember, I've told you always start with what? What has got a complement. But to make things easier for yourself, always include the universal set first before you do anything. So I'll put my universal set there. In other words, I can't go beyond the universal set. It will just remind me. If they've said the universal set is a set of real numbers, it means that it's not restricted. You don't need to put any numbers. But here they've given us a universal set is from negative 10 to 10. So we'll start with the set C. The set C is starting from, because that's the one with the complement, from negative 5 to 1. So let's say negative 5 is here. Let's say 1 is here. And at negative 5 is going to be closed because there's a closed bracket. At 1 is going to be open. This is a set C. But I'm interested in C complement. So at 5, for the complement, it's going to be open. While at 1, for the complement, it is going to be closed. Okay. And then be going to the opposite direction away from C. So we are going to be going in this direction. At 10, I'm going to open. Why am I opening? Because the universal set doesn't include 10. And then from negative 5, also be going in this direction. At negative 10, I also open. Why? Because the universal set at negative 10, it's open. So this is C complement. So I'll get this C complement and first find the intersection with B. So what is the set B? It's from 0 up to 7. 0 is going to be somewhere here. 7 will be somewhere there. And we're including both 0 and 7. So that you just don't get confused, I can even remove the set C because I'm not dealing with the set C. I'm only dealing with C complement and B. This is how you can be answering it. So you started first by writing C and then you wrote C complement. You can write a line like this and then write it again. Just now show where the C complement and then also put B there. So this will be the second diagram you can show when you're answering as in an exam, so that you just look clean. Because trust me, a lot of people fail not because they don't know, but because their work is dirty. You can't write everything on the same place to look dirty and you get confused in the process. You end up writing what's not correct. So we want where these two sets are intersecting. Where are they intersecting? You can see from 1 up to 7 they are intersecting. So the intersection of B and C complement is 1 up to 7. 1 is part of the set B. It's also part of the set C complement. So it is part of both. 7 is also part of both. Okay. So what I can so the meaning of that is that it is like this. That's a complement of B and C complement. But what I can do is I'm going to do this. I'll write it on another number line from 1 up to 7. From there up to there. So what is this one? This is B intersection C complement. But I want where B intersection C complement is intersecting with A. Now I'm going to introduce another set here, which is A, and A is from negative 3 up to 2. So at negative 3 is supposed to be open, at 2 is supposed to be closed. like this. So now I want where these two sets are intersecting. You can see where they're intersecting is just this part. Therefore, we're going to say A intersection B minus A intersection B intersection C complement, which is the same as what was initially given as A minus B minus C complement is equal to what? It's just from, so the final answer is here from 1 up to 2. So we are going to close at both ends because both 1 and 2 are in both sets. Does this make sense? Great. Okay, let's try this one. We are not answering question 2, A and B. We are going to question C. It's saying A is from negative infinity to 3, B is from negative 3 to 3, C is from negative 1 to 6. And R be the universal set. R is the set of all real numbers. So the set of all real numbers is the universal set. The question is saying find A intersection B minus C complement. So the first thing first, let's simplify. This is going to be A intersection, where there is B minus C, we'll put B intersection C complement, right? But remember, outside you have got another complement. What I want you to know is this: we'll talk about the laws in the next discussion. If you have got X intersection Y in brackets and then you have got a complement, you should distribute this complement to the inside. So X is going to have the complement and Y is going to also have a complement. But what happens that the sign changes. If it was intersection, it becomes union, and if it was union, it becomes intersection. This is known as De Morgan's law. We'll talk about it later in the next math class, so you can't forget this one. So this is what we are going to do. We are going to come here, so this will be A intersection. I'll get this complement and distribute to the inside. So I'm going to have B with a complement, and then we are going to have C. It has already a complement, but it is going to now have another complement. This was intersection, it will become union. Remember what we said earlier: when you have got two complements, they cancel, so we just have C. Is there anyone that is behind here? We are good, right? And then we can now come on our number line. Remember what we said: always start with what has got a complement. The set B is from negative 3 up to positive 3, and it is closed at negative 3, it is open at 3. But we are interested in B complement. So since 3 is not part of B, so it will be part of the complement. So I'm going to shade at 3. I'm going to shade. And then I'm going to go in this direction. Because they've not told us where the universal set is ending, so put an arrow because it will just continue going. And then at negative 3, I'm going to open because negative 3 is closed for B. And then I'll be going in this direction. This is B complement. So I want to find B complement union C. So get now the set C. The set C is from negative 1 up to 6. And it's open at both ends. Union means combining the sets. So when you combine the set B complement with the set C, what you are going to see is this. This is B complement. Combine it with the set C. Okay. B complement is the one in yellow. So you have combined like this. So you can see that the sets will be from negative 3 going in this direction, and then from negative 1 going in this direction. So combining just means get the sets that you're interested with. The one in yellow together with the one in green and the one in yellow, put them together. That's union. So this is B complement union C. Now I want where this set is intersecting with the set A, and the set A is from negative infinity up to 3. So 3 is somewhere here. Negative infinity meaning that is coming from this direction up to 3. And that 3 we're supposed to close. So it's going like this. This is a set A. So if you see where these two sets are intersecting, can you see that both have got arrows going in this direction? So meaning that in this region, they are all intersecting up to negative 3. And then they are also intersecting from negative 1 up to positive 3. Okay? Those are the regions of intersection. And therefore, we're going to say that the intersection is from negative infinity up to where this number here, that's a negative 3. But negative 3 is not part of this set here. So we are going to open. And we said that infinity always open. And then another point where they're intersecting is here, from negative 1 up to 3. So 3 is here in the set A. 3 is also in the set that is on top. So we are going to close there. But negative 1 is not part of this set. So we are going to open. So this is the intersection. But because you have got two different points where they're intersecting, you're supposed to combine them. Combining means you put a union. So put a union between them. Okay, you are combining them. So this is how you can be able to work out these sets.